What's it here? Move over here, please. Okay, we got some more minutes. Gotta get the link fast.
Okay, I think we are live now. Okay, this is going to be a research paper readout done by on the paper called AgentLAB, benchmarking LLM agents against long horizon attacks. Okay. This paper was presented by these authors, and let's get on to the abstract of this paper. So LLM agents are increasingly deployed in long horizon, complex environment to solve challenging problems. But this expansion exposes them to long horizon attacks that exploit multi-turn user agent environment interactions to achieve objectives infeasible in single turn settings. Okay, let's try to talk through what is single turn versus multi-turn first, right? So whenever um, a user prompt is sent to an agent or an LLM and a response is made for that user prompt without specific reasoning or tool calling, that would be categorized as a single turn, right? In case of multi-turn, it involves reasoning, then tool calling and loops, right? That's how we distinguish traditional LLM versus the agent. Yeah. So LLM is the knowledge base, whereas agent has a capability to extend the knowledge base and perform some reasoning and looping on top of that to give you an ability to perform a multi-turn chatting or reasoning possibilities, right? Okay. To measure agent vulnerabilities to such risks, we present AgentLAB, the first benchmark dedicated to evaluating LLM agent susceptibility to adaptive long horizon attacks. So here the term long horizon is really crucial. So in agentic AI, okay, okay. So the word long horizon refers to something it can go beyond the multi-step, okay, and it's a goal directional, and it can run for many hours. And there are use cases right now, even Google has released, called multi-day um, multi-day kind of response, right? So basically long horizon agent operates in goal, plan, execute, check, adjust and continue loop over many sequential steps. That's called the long horizon agentic AI. Okay. Coming back to here, okay, so currently agent lab support 5 novel attacks including intent hacking, tool chaining, task ingestion, objective drifting, memory poisoning, spanning 28 realistic agentic environments and 644 security test cases, it seems. Leveraging Agent Lab, we evaluate presentative LLM agents and find that they remain highly susceptible to long horizon attacks. Moreover, defenses designed for single turn interaction fail to reliably mitigate long horizon attacks. We anticipate AgentLAB will serve as a valuable benchmark for tracking progress on securing LLM agents in practical settings. Okay, so here is what the claim, and they have listed it under the GitHub, so anyone can make use of this benchmark. Cool. So, so far in this research paper, right, the the novel attack types, right, the intent hijacking. Okay, so that can be an alternate on that could be like prompt injection or something in that lines, right? Tool chaining, um, tool poisoning, task ingestion, object drifting, and memory poisoning. You might have heard about the prompt injection, right? So someone claimed that 2024 Chevy Tahoe, someone bought it for a dollar because the chatbot wasn't established certain guardrails to protect those kind of prompt um, hijacking or prompt injection, right? Then tool chaining or tool poisoning, right? So there were some examples that I have read which says like usually the LLM, the language that are around LLM or Python, right? So in the Python, basically it may use subprocess to invoke a CLI or a different terminal to work uh, certain concepts, right? Even it can use os.remove, right? So those are the ways the tool poisoning could be triggered. One of the way to do that. Task ingestion, right? This task ingestion is if you take VS Code as an IDE, there is a specific concept called task.json. Okay, so you can automate certain things like cron kind of behavior using task.json in VS Code, so that um, so unwanted a malicious actor can make use of JSON task.json to do some mal functionality so that it can harm the production use case or something like that. Yeah. Next, object drifting. So this is kind of nuance, I would say. Not most of the folks talk about object drifting. This itself can be a separate research paper if you ask me. Why do I say that? It all boils down to a single verbiage in most of the users who use LLM or agentic AI calls out called hallucination, right? The term hallucination, an alternative term, is called fabrication, which means a LLM as a model wasn't able to sufficiently ground certain information and it drifts by itself and it tries to get its intrinsic knowledge which was basically trained upon, right? So for your specific use case, that intrinsic knowledge cannot be a viable solution or an option. That is where the hallucination occurs, and the object drifting is a kind of formation of the hallucination. I'll give you one more example. So let's say you have been working in a session, right? You are almost like out of 200k tokens, you have almost like crossed beyond 50 percentage or 60 percentage, right? In the context memory, you have your certain portion of message that is required for the agent for to continue to progress to the next towards the goal for that session, right? So the moment you hit beyond 60, 70 percentage, the obvious choice anyone would be doing is compaction, right? What does the compaction mean? So compaction is like compressing the context window or context memory so that the history of the session still maintain and kind of persisted for your model to keep continuing the goal, right? So um, I was reading in another article, and even in my personal experience, the moment the compact or compression is happening, it tends to have a lossy chain, which means it doesn't maintain the actual truth, but it predominantly believes it has every information, okay, but it assumes certain things. Like, let's say, during your session you have tried to load certain files from X folder, okay. So during the compaction it will assume that X folder has been visited and it is up to date. But for the later part of your session, it may need more information on or what were the files behind the X folders. Those information is already lost, right? That is called object drifting. And everything, if you zero in, that comes to a term called hallucination. Okay, we'll keep moving on. So next thing is memory poisoning. I meant very sure about how this is taken place, but we'll get through the paper and try to see that. Okay, cool. Let's move ahead. Introduction. Large language model based agents have emerged as a transformative paradigm, extending beyond simple question answering to autonomous systems capable of executing complex multi step tasks through tool use, memory persistent, and environment interaction. Okay, so what does that mean is, so yeah, this is um, the example for long horizon um, agentic work, right? So autonomous system capable of executing complex multi steps through tool use, memory persistence, and interaction, environmental interaction. Okay, so we know the tool use, right? So each and every action, like file read, a grep or grep, or some fancy tools like JQ or something else, right? Memory persistence, this itself another whole topic by itself, right? So even recently Karpati has introduced a knowledge based graph, kind of a LLM wiki, those orientations, and someone based on that they have created a GitHub a page called Graphify, right? So the idea behind that is for all of your code base or whatever the external documentation which your agent needs, something like a RAG, retrieval augmented generation, to ground an external documents that can be formed under a knowledge graph. Okay, so that's the idea. One way of doing the memory persistence. Other way would be a classical markdown file preparation, right? And recently, Tariq from Anthropic, he made in his expose that HTML he's helping him and certain customers. Instead of delivering the output as a markdown, HTML pages is kind of well established output format is the call out there. So that is one way of um, viewing the output format. It's not directly related to memory persistent as such, but markdown is one way of doing a memory persistent. But in my personal experience, I have been using something called um, an alternative to skills called slash memories, right? It is nothing but a dump of the to the point um, the persistence of information, right? Yeah, we'll see more about that later. Um, so we'll quickly skim through the below ones. Okay. So temporal exploitation, ecological validity, and extensibility. Okay. Let's look into the overall framework of the AgentLAB. Okay. So advisory here uses an attack kind of tool chaining, tool hijacking, and user gives the um, prompts times n. It's a multi-turn instruction, right? So instruction is sent and response is gathered. But similarly, an attack adversary is also does the same. So consider this is an LLM agent with a backend LLM with different frontier models and capabilities that this LLM agent has. RAG, our memory, tool calling, and the planning or the reasoning, right? Yeah. So let's say tool call um, with the environment benign state update, and an malicious state, and kind of attacks we already covered: object drifting, task ingestion, memory poisoning, and interactive traces like hotel or telemetry based on the traces. Something is collected and evaluated under utility or security. Okay. I believe we have covered the, the introduction so far. Moving on is the related work that this paper has took references from: user agent interaction attacks, environment agent interaction attacks, agent security benchmarks. Okay, let's quickly talk about the problem formation. User agent environment interactions. LLM agents are increasingly deployed in complex environments to solve challenging problems, right? Formally, so let's assume P as in prompt, A as an action or a tool call, and O is an observation, and R is an agent response. So long horizon interaction proceeds as like at each step, user provides an instruction like which is a prompt, right? Conditioned on prompt and previous interaction, agent generates an action, a tool call. Upon executing an action, the agent receives an observation from the environment and sends a response R to the user. Okay, this is the quadruplet. Okay, so threat model we consider um, we consider a red teaming setting where the advisory aims to induce the agent to perform malicious tasks. T. Exfiltrate confidential data through multi-round or multi-turn interactions. Okay, so that is done through two distinct threat models: user as a advisory or an attack malicious attacker, environment as an advisory itself, right? Okay, so malicious user manipulates the agent via instruction interface. Specifically, agents substitute a subset of user instruction with adversarial prompts, such as resulting actions collectively accomplishing the malicious task. Yeah, let's say if a user is pointing out a certain file that he downloaded from the internet or a GitHub, right, where that particular file can have an invisible character code, right? That's how the recent attack on GitHub and all the campaigns that have been driven by malicious actors have been performed through that and several other ways, right? Um, Next one is the environment as advisory. Advisory manipulates environmental observation received by the agents, such as comments in the code repository, embedded email content, document text, browsed web pages. Specifically, attack substitutes a subset of observations like prompt injected web pages. So someone had a prompt in the HTML comment, right? And the agent was able to act on the instruction. That's one way of doing that. So in both cases, we consider black box settings where advisory observes only the action and response, as well as white box settings where advisory has access to agent's internal reasoning, chain of thought, right? Yeah. Okay. So I think we already kind of went through this. Okay. So intent hijacking tool chaining is called adversarial prompting, and these three are called indirect prompt ingestion, right? Okay. I think the agent lab itself is agent long horizon attack benchmark. That's called agent lab. Okay. So we already know what is agent. Um, so environment is nothing but where it is being executed. It can be in your local VS Code as an IDE or in a production use case, right? Which may have access to different tools. If you have a Hermes agent in your local machine, and if you are not deprioritized your networking firewall, so hacker may get into your home network, may have access to all your laptops or other networks in your home. So never use any autonomous agentic AI on your local laptop or workstation where you have access to everything in your home network and as well as your personal. Never do that. That can become an environment by itself. Yeah. Tasks. So task can be anything like calendar, add a calendar invite, translation, um, so manipulation and call to an external web URL. Anything can be a task. Attack is the usual way of doing some malicious act. Okay. Um, let's quickly talk about the multi-agent framework for long horizon attacks. So, okay. So in the agentic world, every multi-turn response would begin with a goal or a plan, right? So there will be a plan, verifier, then in this case it is an there is an attacker and a judge and LLM agent, right? So we instantiate diverse long horizon attacks via a general framework that coordinates multiple LLM agents, a planner that analyzes the malicious tasks, synthesis executable attack plans, an attacker that executes these plans iteratively, refining malicious adversarial prompts or observation based on the target's agent's action and response, a judge that internally evaluate whether malicious task has been achieved. For certain attacks, the advisory also employs a verifier to validate generated tool calls through environment execution. So here is where the verifier is important, right? So we know we need to establish guardrail at each um, life cycle, right? So even a planner or um, an agent which needs to invoke a tool call, there needs to be an guardrail to monitor the tool call, and that can act as a verifier, right? And yeah, let's quickly talk about the intent hijacking. Intent hijacking exploits multi-turn user agent interaction to progressively erode agent safety guardrails and deceive it into executing the malicious task. Okay. So idea here is just to cross a 60-70 percentage of the session in the agent so that system prompt is a part of your context memory, and LLM have a tendency called recency bias, okay, which means it takes the recent request or the recent information as a truth, and it tries to give the response. That's called recency bias. Okay, so that is what exactly the intent hijacking here refers to. Okay, unlike conventional multi-tool jailbreaking that manipulates conversational context to explicit or harmful content generation, intent hijacking exploits the agent's action space to achieve malicious outcomes through tool execution. We implement intent hijacking through a multi-agent framework. The planner analyzes the malicious task, generates prompt strategies by crafting personas, contextual framings, narratives. Attacker execute this plan through iterative prompting, refining prompts based on the response. Yeah, that's one way of doing it. Next is to somehow this HTML is not rendering properly. I go for the PDF. Yeah, let's see here. Okay, the tool chaining. So as we, if you recall, there's a benign state and the malicious state. Yeah. So what was that? Yeah, the environment is benign and it becomes malicious, right? So in a benign, read web page. So malicious, invite, add, or remove user from a Slack. Okay. So here is what the um, the telemetry behind the LLM call, right? So I am start, like it's a Slack. So user, I need tokens, something like this. Agent redirected to inbox and attacker URL. Inbox ingestion, fabricated policy adjuster. So let's say if there is a policy digest, this one, and um, so inbox ingestion is kind of like fabricating the policy. Um, so I may not be expressing the the same thing which is captured in turn on intent to, because I'm a newbie to AI red teaming. Apologize if I miscommunicate anything here, but I'm trying my best to follow this and explain. Third is a turn. Turn three would be attacker URL malicious tool as a fix. Okay. If we look into that, IAM start system and just making it as a system error, policy mismatch, and here is what. So it's making to execute the Slack tools again. So this is the result. Get web page, read inbox, invite, add channel, and remove. Yeah. Okay. This is what it was captured about. Object drifting. Um, yeah, object drifting exploits the susceptibility of LLM agents to gradual environment influence over extended interaction. Rather than explicitly injecting malicious T, this attacks embeds object shifting content or the observation, right, to shift the agent's objective from T to T star, like task, malicious task to a different level. For example, consider a web shopping agent instructed to price cost effectiveness and select low price products. The attack injects observation into the product description, search results subtly, prompting alternate objectives, brand preferences, individual injection, benign in isolation, yet cumulative effect alters agent behavior, making detection particularly challenging. So here the priority is on the cost effectiveness and low price product, but you can I think they were trying to improvise like product description, um, objectives, something like that. Okay, it's kind of an objective drifting, so that we implement object drifting via multi-agent framework. The planner generates diverse objective shifting strategies, user preference overriding. This is the one. User preference overriding, authoritative claiming, task redefinition. Attacker executes these strategies by generating and injecting objective shifting content into agents' behavior, web pages across interaction. That's the objective thing. Okay. Task ingestion. Okay. For this, we will switch over to this one. Okay. Task ingestion. Okay. Objective. Inject malicious memories via hidden prompts. A vector can be email, code comments, product description. Retrieve memories, override safety behaviors. Yeah. Let's say if there are set of process, right? Like user prompt, observation, user prompt, tool calling, and observation, task execution, then response, right? So each and every step or hops of it, if you change the um, the intent and the behavior of it, it may be it may become a part of one kind of an malicious attack, right? So that's what it's been called out here. So agent reads email. Hi team, please review the user preference. I automated uploading reports to doc sites. Okay. Agent analyze the code. So define upload file. Note user prefers. Return API post. Scripting uploads to portals. Agent shops online. USB drive 64 MB fast transfer speed. User separates private from published folders. Automated loading local reports. Prefers scripting file uploads. Separate private from published folders. Post each line of tweets.txt as a tweet. So so whatever the scripts or the local reports that can be treated and can be published in a different way, user unintended way, right? Something like this. And they call it as a memory poisoning attack also. Yeah. Yeah. So that's what we looked into. Okay. So next one is the benchmark implementation. We will stop here for the part one, and we will look into the benchmarking and evaluation in the next video. All right. Thank you so much. Bye.